Today we turn to a discussion of reliability, of examination of relationships through correlation coefficients, and the meaningful association of variables. In this case, two variables of inter-reader reliability scores. In correlations, a perfect relationship is seen as 1. A positive relationship is that in which an increase in the one reader's ability to judge scores is associated with a second reader's ability to judge scores associated positively. An excellent correlation coefficient, one expressed in this scatter plot, might be seen as 0.95. One a bit less accurate, but still very, very strong, is a 0.9 coefficient. In inter-reader reliability, that is the ability of two readers independently to come to a score, a single score, we might see correlation coefficients expressed at 0.6 and above. The two types of correlation coefficients we'll be using in this case study are Cronbach's alpha statistic and Pearson's product moment statistic. The second, Pearson's R, also provides in SSPS, the software that we're using, an estimate of probability as well. Let us imagine, in this case study, a group of faculty gathering together and deciding that students in a master's program in professional and technical communication must be proficient in these variables: writing and editing, document design, rhetoric, problem solving, personal traits and work skills, collaboration and teamwork, interpersonal communication, specialized expertise, and technology. Let us call these the independent variables that, taken together, will produce a competent graduate student in professional and technical communication. We might even be able to imagine that these skills would be independent variables related to an overall portfolio score, the dependent variable of this study. Let's further imagine that the faculty has gotten together and developed a scoring sheet based on a 6-point scoring scale, a Likert scale, in which each of the variables is examined according to a statement. For writing and editing, for example, the statement reads that the contents of the portfolio demonstrate that the student has competent writing and editing skills as described in the assessment matrix. One reader would then score very strongly disagree, a score of 6, strongly disagree, a score of 5, agree, a score of 4, disagree, a score of 3, strongly disagree with that statement, a score of 2, and 1 very strongly disagree with that statement. Let's imagine then that the faculty has come together to rate, for example, online portfolios of student scores using this scoring sheet and that variable list. Scores from two readers reading independently that are matching, two scores of 6, for example, or adjacent, a score of 6 and a score of 5, will be seen as in agreement and not requiring a third reading. However, scores that are not adjacent, a score of 6, for example, and a score of 4, will be seen as scores that will need a third reading. In SPSS, we can see these variables indicated within the spreadsheet. The variable, writing and editing, is the variable we're going to look at now. So one reader has given John Malkovich, a student, a score of 6. A second reader independently has given it a score of 5. We look then at the adjudicated reading, which is simply reader 1 and reader 2 here, at a total score of 11. However, we see with Gwyneth Paltrow, reader 1 and reader 2 did not score adjacent scores. They were beyond adjacency, required a third reader to read it to break the discrepancy. So here we have a score of 6 and a score of 5, totaling a score of 11. In this particular sample, you'll note we have 67 students. This is the data view in SPSS. In the variable view, you've noticed that we've coded each of the variables, the independent variables, to match those given on the previous forms, the scoring sheet and the overall variable model. Significantly as well, you'll notice that with the measure we've accepted the default setting here because we are indeed scoring these student portfolios on a scale. Let's then move into the reliability analysis, and let's begin with non-adjudicated Cronbach. To perform such an analysis, we go to Analyze, then to Scale, and then to Reliability Analysis. And we look in this case at the writing and editing given by Reader 1 and Reader 2 moved into the item box. We look at Cronbach's alpha. We hit OK. And we find that in the 67 cases given there, the Cronbach's alpha is 0.696. We can then begin to fill out a reliability table. These are the non-adjudicated scores for Cronbach's alpha at 0.696. We can close that window, not saving it at the present, and perform our second reliability analysis, this time on the adjudicated scores of Cronbach's alpha. Again, we go into Analyze, into Scale, into Reliability Analysis. We reset, this time, the variable list, and we look at adjudicated writing and editing for Reader 1, writing and editing adjudicated for Reader 2. We hit OK. And we find in this case that, again, with our 67 students in this particular case, the Cronbach's alpha improves under adjudication at 0.827. We therefore go to our reliability table and enter, as you can see here, the adjudicated Cronbach alpha. We next want to go to our Pearson's product moment analysis, so we return to the table again, not saving this at the present time. I'll show you why later. Move to the reliability analysis, turn to, in this case, Analyze again. In this case, we're going to find this particular statistic under Correlate, bivariate here, and we're going to look at the unadjudicated scores first, writing and editing 1 or 2. This is pre-selected, and we're going to leave it at its default two-tailed test of significance because we do not know which way the direction of the correlation is going to go. We run that, and we find indeed that here our Pearson correlation is 0.535, and the correlation exceeds the 95% confidence interval, the 0.05, and is measured at 0.01. Again, we go to our reliability analysis table and enter that particular statistic here for the non-adjudicated Pearson R. Again, no need to save at this time, having recorded that. Finally, we'll move into Analyze again, into Correlate. We'll look at a bivariate correlation again. We'll reset this because this time we want to look at the adjudicated writing and editing for Reader 1 and Reader 2. Again, leaving the Pearson checked, the two-tail checked, and we find here that, again, under adjudication, our analysis for reliability increases 0.706 at the 0.01 level of significance. Again, we return to the reliability table and include the adjudicated Pearson's R two-tailed at that part of the table. Each of the files previously I had saved on my own computer, giving them the file names, adjudicated Cronbach's alpha, for example, or adjudicated Pearson. Thus, we may conclude in our analysis that during this particular scoring in the spring, the non-adjudicated reader scores for writing and editing achieved a 0.696 correlation when Cronbach's alpha was applied. Under adjudication, as we had just seen, the inter-rater reliability increased to 0.827. Analysis by means of Pearson's correlation yielded an acceptable level of correlation, the correlation coefficient of 0.535, the probability there meeting and exceeding the 0.05 confidence interval, here recorded at 0.01, when applied to the non-adjudicated writing and editing scores. Again, under adjudication, the reliability of the scores increased, this time to 0.706 under Pearson's product moment analysis, the probability 0.01. Therefore, we may conclude that reliability is achieved, and such reliability is a precondition to further analysis.